Hey, howdy, and welcome back. So, hopefully, the motivations for always writing readable code helped, I don't know, motivate you to do so, as that was their intention. We're now moving on to sources of errors, your program, and defensive programming. So, what are the sources of errors in some of our programs? First one could be poor specification. Maybe you're making guesses as to what some sort of thing's supposed to do, and what your assumption is didn't really meet up with expectations. If you're ever going through a machine prompt and you're not sure what you're supposed to do, go ahead and ask for clarification. It's important to ensure that you're actually implementing what it is you're supposed to, opposed to going about the process and thinking you're implementing the correct thing despite not doing so. The second one, source of error, is incomplete programs. Maybe you're putting something off for the next day and you think you're going to get around to it, but you never do. And then that little component of the program was never resolved or never fixed or otherwise. And eventually it comes up again and produces an error in your program. In addition to this, a common source of error, probably particular in this class, will be unexpected arguments to functions. For instance, you might write a basic square root function. You've done a pretty good job on it. You've considered all the common cases, but you haven't considered, say, the fringe cases or the uncommon cases. And maybe for square root, you'd consider this common, but what if square root is called on some sort of argument with a negative value? You have to account for things like that. Unexpected input. Well, you might be asking the user for, I don't know, input a character or integer value, and they could give you a string. There's it's You can never rely on the user to always do precisely what it is you're telling them to do correctly. Furthermore, and this will also be probably a bit common in this class, more so than you'd like, is you might write some code and it's just not doing what it's supposed to do. And the solution to that is to go ahead and probably fix it. But it's not always easy to track down where that code that's actually executing or performing the incorrect sequence is functioning incorrectly. So we'll see later on in this week that a combination of testing and debugging can help you isolate and determine where that code is that's unexpected, that is executing in a manner that's unexpected and producing perhaps erroneous results. So from this point forward, what our kind of expectations of your programs is going to be is that you should really produce the desired results for all legal inputs. Moreover, if a user, say, attempts to pass your program illegal input, that some sort of reasonable error message is going to be presented to them so that an error does not actually occur. Instead, we catch it before there's any sort of chance for things to go wrong. You never have to, at least in this class, worry about misbehaving hardware. You don't, well, you have to get in touch with us if maybe your VM's not working. But you don't need to consider those cases in your actual program. For instance, what if the keyboard's disconnected and I'm bound to standard IO or standard input, things of this nature. You don't need to worry about misbehaving system software. Well, to actually develop this, your VM needs to be functioning correctly, but your application doesn't really need to know whether or not something's misbehaving behind the scenes, and you definitely don't need to address that. Instead, you'd come to office hours and we'd help you resolve whatever it was. And unless specified otherwise in this course, it will be completely acceptable to terminate after your program has encountered an error. Of course, you should provide some sort of descriptive message to the user to communicate why the program or application terminated early. So here's a concept, defensive programming. I took this from Professor Zillis's, one of his lectures. Defensive programming, the key idea is to protect yourself from invalid inputs. And the question is, well, where does the invalid input actually come from? It could come from the command line arguments that are being passed into your program. A user's entering them, they could enter them incorrectly in the wrong order. There's a number of ways how an incorrect invalid input could come from the command line. Moreover, and likewise, user input while your program's actually executing. You might prompt them for some sort of input, and they might not oblige to the format that you're requesting they provide it in. Programming errors, I mean, this will happen. Bad data files would be another area where invalid input could arise from, as well as configuration. So what we're going to essentially really encourage you to do and require in other cases is to always check all data from external sources, including input parameters.